In example 4, we need to find the value of the variable in each of the pictures below. So if we look at A, we have a triangle. It appears as these two angles are congruent. Therefore, the sides opposite, so we're talking about the 20 and the x here, those will also be congruent. We've got a little isosceles triangle here. So we can set x equal to 20, and we don't have to really do any more work with this one. We're good to go. In part B, we're given that all three sides of this triangle are congruent, meaning we have an equilateral, and that also means we have an equiangular triangle. So we have to ask ourselves, if this one is S here, this one is going to be S, and this angle is going to be S. So when we add S up, or 3S, that's going to be equal to 180. S plus S would be 3S. Now we can divide by 3, and S will be 60. Notice how the degree symbol is already here, so we don't need a degree symbol there. That would be a degree of a degree, which I'm not sure what that is. So this is 60, and that's fine. In an equiangular triangle, all three angles, or an equilateral, same thing, all three angles are 60 degrees. Looking at C, we also have an equiangular triangle, meaning that all of the sides are congruent. So I'm going to make some tick marks here, and here, and here. Now we know that x plus 3 is equal to 2x minus 1. Those sides are congruent, their measures are equal. If we solve here, I'm going to choose to subtract x. There's actually a few different moves you could make here at this point, and we move this up a little bit so you can see it. And let's see, we've got x here, 2x minus x is x minus 1. I'm going to add 1, and x will be 4 for this one. You could verify that result by plugging it back in or substituting back in. So 4 plus 3 is 7. 2 times 4 is 8, minus 1 is 7 again. So we're good to go. For part D, we see we have two sides that are congruent here. So we know that the angles opposite of them are going to be congruent. So 2x will be equal to 32. Divide by 2, and x will be 16. That's the value of x that makes this given information work out. If we look at the top, the instructions say find the value of the variable in each of the pictures below. And we've done that. You can see here that we don't need to find actual side lengths. We do need to find the value of the variable. And if you wanted to double check your work, you could totally substitute that back in.